Alrighty, so like I said, y'all, 9.4 is going to deal with logarithmic functions. So y'all, basically, let me tell you what a logarithm is. A logarithm, it finds the exponent that a base was raised to get the result. So basically, you can think of a logarithm as an exponent. Okay, so let me show you how they come. All right, so log is short for logarithm. It's going to have a base right here and a result. So A is the base or number being multiplied. The Y here, so the base will be like a little subscript next to log. The Y here, that's the result you're looking for. So what we look at, this logarithm right here, what it's going to find, you can treat it like this. A to some exponent is going to equal Y. So we're going to know the base. We're going to know the result. When we plug this in, it's going to find me the exponent right here, okay? So let me give you an example or a couple examples so that y'all can see what I'm talking about. Oh, and y'all, these are just going to say something like find the logarithm. And y'all, I'm going to actually bring up my chat so y'all can do some of these with me. All right, y'all, so my first one I'm going to do, how about a log base 3 of 9? So y'all, what I need to know is what exponent would you raise 3 to be a 9? Now remember, I'm not multiplying 3 times itself. I'm multiplying 3 times itself. How many times? So I would think of it, Charles, you got it right up there, number 2. That's it. Because think about it. 3 times 3 equals 9. So that was multiplied 2 times. Okay? Try this one. Log 5 of 125. How many times would I have to multiply 5 times itself to equal 125? And y'all got what, a 3 up there? Good job. Because remember, this would be 5 times 5 times 5. That equals 125. And we done that 3 times. So this would be like 5 to the third power equals 125. This would be 3 squared equals 9 and so on, okay? So that's going to be the trick in this section is realize we're finding exponents, okay? Now, before we start finding a lot of logs, they want us to graph a few of these. Um, so let me go and do a graph here. And what I'm going to graph here is y equals a log base 2 of x. Now, in MATLAB, you don't have to graph these. You just got to pick one of the 4 pictures. But I sort of wanted to graph these because these, you're sort of picky on the numbers you're going to pick. Okay? Now, I will say this. These graphs, and you'll notice when I get done, they make a vertical asymptote with the y-axis. And then they never, in this form, x's can never be negative, okay? Because there's no exponent I can raise a number to get a negative answer. So these can never be negative, okay? All right, y'all. So I'm going to make a little graph table here real quick. Now, I can't even choose a 0 for x because there's no exponent that I can raise a 2 to make that equal 0. That's not happening in the real world. So the smallest x I can put up there would be a 1. Now, what exponent would you raise a 2 to make it equal 1? So that's like this. 2 to some exponent is going to equal 1. There's only one exponent that can do that. And it can do it to any number we learn. And that exponent would be 0. Remember, any number to the 0 power is going to equal 1. So when I got a result of 1, that means the exponent has to be a 0. All right, I would pick a 2 on this. If I put a 2 here, I'm looking for the exponent that I would raise 2 to make that a 2. Well, y'all, that means this exponent would have to be a 1. 2 to the first power equals 2. Now, y'all watch this. I'm not going to put a 3 here because 2 don't multiply by itself to get a 3. So that means you would get a decimal type answer. And I want to avoid a decimal. So the next number I would pick would be a multiple of 2, would be a 4 here. So let's see. That would be like 2 to what exponent is going to equal 4? Well, y'all, that means that the exponent I'm looking for would be a 2. 2 squared equals 4. And y'all, let me try one more. So I'm not going to put a 5 here, a 6 here, or a 7. The next number I would put would be an 8. So you got 2 to some exponent is going to equal 8. Well, y'all, that would be a 3. 2 times 2 is 4. Times 2 would give me 8. So that would be an exponent of 3. So let's see what we got. My first point would be 1, 0. So write 1 and stay right there. So every logarithmic graph will go through this point. I had 2, 2. So y'all, that's right, 2 and up 2. I had 4, 2. So that's right, 4. Oh, y'all, I did one bad. That should have been a 1 right here. Because remember, I put a 1 was my exponent. So scratch that point, and this would be a 2, 1 right here. And then I would have 4, 2. And then 8, 3 would be over here. 5, 6, 7, 8, and up 3. So these graphs sort of go uphill very slowly to the right. Now on this side, it's going to sort of make a asymptote with the y-axis, and then it comes through, and it's just going to slowly go uphill to the right. All logarithmic graphs will look like this, okay? So if you want to do these on the calculator, let me share the calculator. Now, since I got a log with a little 2 for the base and then my x, let me show you where you got to get that at. So go to y equals. You're going to click the math button. And on the math button, you're going to arrow down until you find the log base. Once you got the log base, you click enter. So mine had a 2 for the base. So I'm going to put in a 2 and then an arrow right, and I'm going to put in an X. So now I got my equation in. Let me show you the table. I'm going to hit second graph. And y'all see, you can't use the 0 for X because that gave me the error. So there was 1, 0, 2, 1. Notice at 3, remember I said you get a decimal. So at 4, 2, and so on. And then let's look at the graph. And there's that graph. So they're all going to make the basic same shape, okay? All right, y'all, then you got one that, I will say this. I won't graph it by hand. But my number 2 on mine has f of x equals log of x. So let me explain this one a little bit. On the front of your calculator, there is a button that says log. That's what I would use for this one. If there's not a base right here, if there's not a base shown, it's automatically understood to be a 10. Okay? This is what we call a common log, a log base 10. So they don't have to write the 10. It is understood to be there, okay? So on this one, I'm going to use the log that's on front of the calculator. And it's right to the left of the 7. Right to the left of the 7, hit that log button. And then put in your X. Now, y'all, what's cool is if you look at the graph, it's going to look exactly like the last graph I had. The only difference, since it's a base 10, it's going to be a little bit flatter. So the higher the base, the flatter these graphs get, okay? And then if you wanted to look at the table, look at that. All the points in between 0 and 10, since this is the base 10, everything in between 1 and 10 is going to give you decimal type answers, okay? All right, another special log on my number 3. They want me to do f of x equals the ln of x. This ln here, it's a special logarithm. It's a logarithm base e. Y'all remember the little e we did on Tuesday night? So this is called the natural log. And that's a ln, not an I. It's a ln. And it is actually a log base e. So log by itself is a log base 10. ln is a log base e. And y'all, you got an ln button on front of this calculator. So let's go to that and see. I'm going to go to y equals and clear this out. ln is right next to the 4. So to the left of the 4, you got the ln. Put in your x. Now, what you're going to like about this, the graph is going to look exactly the same. It's just going to be not quite as flat as that last one. Because remember, E is around 2 point something, so the graph will be a little more, increasing a little more than the base 10 did. But all the graphs, you can punch them right into the y equals, okay? So if you got a log with a base, you're going to hit math and go down to log base. If you got a logarithm that has no base, that means it's a log 10. You're going to use the log button on front of the calculator by the 7. If you got an ln, that means it's a natural log, and you're going to use the ln button next to the 4. Okay? Okay, also, what we're about to do now, we're going to start finding logarithms. Now, some of these, I got to show you some things that you got to recall from the past. But most of these will be straightforward. These are starting at number 4 for me. So I'm going to do a log base 2 of 32. Now, I'll show you how to do these by hand and on the calculator. So let me ask y'all this. How many times would y'all multiply that 2 times itself to get me a 32? All right, Andrew, that's perfect. 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So a log base 2 of 32 was going to spit out a 5. And y'all listen, y'all got the calculator, so let me show you on it real quick. So I'm going to get off the graphing, so let me hit second mode and quit. So to get that was a base 2, so I'm going to hit math. I'm going to arrow down to log base, hit enter. I had a 2 for my base, and then arrow right and put in your 32. All right, y'all, there it goes. Log base 2 of 32. When I hit enter, I get 5. So remember, all these can be done on that calculator, okay? All right, y'all, let's see what y'all do here. My number 5 is a log base 6 of 36. All right, so a log base 6 of 36. What exponent are you raising 6 to equal 36? All right, Charles, that'll be a 2. Good job. 6 times 6 is 36. All right, y'all, a log base 10 of 10. Now, in the beginning, they're going to put a 10 here, but later on, they're not going to put that 10 here, and I need to understand that it is a 10 there, okay? So what exponent would y'all, okay, Angela, you got that, right? 10 to the first power equals 10, so that's going to give me an exponent of a 1. All right, y'all, watch this one. Number 7, log base 4 of 1 over 256. If you got a base raised and the result is a fraction, you're going to get a negative exponent. Okay, y'all, so that will give me a negative exponent. So y'all push that in, go to your log base. You got a base of 4, arrow right, and put in 1 divided by 256. And y'all get what, so remember, it's going to be a negative. All right, Angela, what do you got? -4. Good job. Okay, y'all, I'll show you that one. Since it's a fraction, I would go math, arrow down to log base, enter. I would put in my 4, and then arrow right, I'm just going to go 1 divided by 256. Now, once I hit enter, I get a -4. Hey, y'all, so the calculator, like I said, will do them all. You just got to know how to put them in there, okay? What about this one? ln of e. So y'all, you got an ln button on your calculator, but let me remind y'all, remember ln of e is like this. It's really a log base e of e. So what exponent would you raise e to make it look like an e? Charles, good job. That is definitely a 1. So y'all, there's a little property we can say about this. Because here, 10 matched the result, I got a 1. E matches the result, I got a 1. So y'all, the log of anything for a base, if it matches that result, that is always going to equal 1. Okay. All right, y'all moving up. How about this one? Log of 1 over 10. Now, y'all remember, I can use the log on the front of the calculator because this is a log. There's not a base here, so technically that's a log base 10 here. And it's a fraction. Remember, we said fractions will give me negative exponents. So y'all punch that one in and see what we get. Looks like y'all are getting what, a -1 on that. Good job. Y'all, let me go. I can use the front of that on that calculator. I can just punch in log and do 1 divided by 10. Hit enter, and I get my -1, okay? All right, y'all, here's another one. Log base 5 of 5 to the 4th hour. What exponent would I raise this 5 to make it look like a 5 to the 4th? Hey, also, here's what I got. I got 5 to some exponent is going to equal 5 to the 4th. All right, y'all popping up now. Good job, Caleb. And then Charles, good. That's going to be a 4. So check out this property. This property says if you got a log of a base and it matches that number raised to an exponent, then the answer will always be the exponent. Okay? And that makes sense, right? Because that has to be a 4 if that's going to look like that one, okay? All right, y'all, this one I'll show you something on this one, y'all. This one's got a log base 2 of the 6th root of a 2. So y'all, let's see. I'm going to show you how to convert from a radical into an exponent fraction, okay? So watch this. We got a property that says a to the nth root of a to the n. So this is a to the n to the nth root. We can write that as a exponent. So bring out the base, and then the n would be the top number of the exponent, and the root, which is the m, would be the bottom number of the exponent. So this is how you convert from a radical into a fractional exponent, okay? So let's take this 6th root of 2. So y'all, let me ask this question. This 2 doesn't have an exponent by it. So what would y'all put for the exponent on that 2? Okay, Angela, that would be a 1. So treat that like a 1 there. So that this will become 2 exponent of 1 over the root of 6. So this becomes 2 to the 1/6. So all of y'all's, depending on what number you have here, that's going to be the bottom number of that fraction, okay? So now that I've converted this radical into that exponent, this now becomes a log base 2 of 2 to the 1/6. So y'all, the question is, if I punch that in right there, what answer will that give me? And recall this little property right here. We got log of a with a result of a to the b. Charles, good job. That's going to equal the exponent of 1/6. So there's my a and my a to my b, which is a 1/6, okay? So check this out. If you got a radical like this, a square root, a 6th root, whatever root, the answer will be a fraction. So logs of fractions give me negative numbers. Logs of radicals give me fractional answers, okay? Oh, y'all, so I'm going to keep moving on then. Let's see, we're on my number 12. Log of 10 to the negative 7th. All right, y'all, what's that giving me? Oh, also, you better remember there's not a base here, so you got to remember what that base is going to be. And remember, you can punch this one in on the front of the calculator. Let's see, Caleb, what you got? -7, Charles -7, Angela -7. Good job, everybody. It's -7. Because remember, this one, since it didn't have a base, was actually a 10. So the base matches the um, base of the result raised to an exponent. All right, y'all, watch this. Log base 256 of a 4. Check this out. Anytime the result is smaller than the base, you're going to get a fractional exponent answer. Now, y'all, when you punch this in, it's going to give you a decimal. So let me show you how to do that back. Angela, good job. Good job. That's definitely going to give me a fraction like that. So I would go to my math and down to my log base, hit enter. So my base was 256. Then I would arrow right and put in my 4. Now remember, like I said, it's going to give me a decimal. So if you hit the math button and enter twice, it will turn the fraction into it'll turn the decimal back into a fraction. All right, good job on that. So these will be fractional answers, okay? All right, y'all, what about this one? Log base 11 of a 1. Now check this out. I don't care what this base is. If that answer is a 1, there's only one exponent that y'all can raise anything to equal 1. And let's see. Angela, you on the road tonight, girl. That is definitely a 0. So y'all, a property about that says the log of any base, if it equals 1, will equal a 0 there, okay? All right, y'all, a couple more and then we switch the topic over, okay? So what about this? ln of e to the -3. So you got to remember what an ln really is. Well, Charles, that was pretty quick because the ln is really a log base e. So that's the e base with an e raised to an exponent. It is definitely going to equal that exponent. So y'all, let me show y'all the way that you would sort of plug that one in because so I had ln, that's right by the 4 here. So hit ln, and then right above that ln button, you see that blue e to the x. So I'm going to hit second ln, bring up that e to the x, and I'll just put in my -3. And then y'all at that point hit enter, and you get the -3, okay? So that's what I like about this section is the calculator really, really can help you out on a lot of these, okay? All right, so I'm going to throw a little bit of a curveball here. How about an ln of a square root of e? So you remember a while ago when I was converting these radicals? What exponent would this give me? So the first question, what's the exponent by the e since there ain't a number there? So that's a 1. Good job. So here's the second question. What's the root of the radical if there ain't a number out here? A 2. Good job. So remember, a radical, if you just have a radical by itself, it's doing a square root, which is a 2. So this becomes e to the 1/2. So y'all, you got an ln of e to the 1/2. So what's my final answer going to be? 1/2. Good job. All right, y'all. So that's just an introduction on what these logarithms are finding, and really it's just finding exponents, okay? So for the next couple sections, we're going to convert because these logarithmic functions are inverses of the exponential functions we did Tuesday. So we got a little property on these. So it says if I got a log base A of y, if that equals x, then this double-sided arrow means if and only if a to the x equals y. So this is the logarithmic form, and this is the exponential form. But next week when we start solving equations, we got to be able to switch between one or the other, okay? So look here. The base of the logarithm is the base of the exponential. Um, the exponent or the answer of the log is the exponent of the exponential. And then the result is the same as the result of the exponential, okay? So when you convert, you're going to use this direct conversion here. And this double-sided arrow means I can go either way. I can start with exponential and write it as logarithmic, or I can start with logarithmic and write it as exponential, okay? So these next few examples are going to be converting. First, we will convert to logarithmic. So I'm going to do a couple of these ones. So I'm going to do one like 17. I got 10 to the 5th equals 10,000. All right, y'all. So here's what you're going to do. I need to write log down first, L-O-G. So the first question, what would the base of my logarithm be? So where do y'all put it for the base? So it's going to be a 10. So actually, when I do my final answer, I ain't even got to write the 10. I can just put a log and that'll give me the um, same answer, okay? All right, the result is at 10,000, and that's going to equal my exponent of a 5. All right, let me do one like number 20. Number 20, they're being a little tricky with. They got T to the W equals 121. Now, y'all, here's the thing with MathLab. These are lowercase letters, but in MathLab, if they use lowercase letters, you better write the answer with lowercase. And if they use uppercase or capital letters, then you got to use those, okay? All right, y'all, what's the base of this logarithm going to be? All right, that's a P. What's the result going to be right here? All right, 121. And that's going to equal your exponent of AW. Good job. Oh, yeah, so that's all there is to it going from exponential to logarithmic. So let's do a few going the other way. Let's on these ones we're going to convert to exponential. So we're taking it the other way now, okay? So they're giving me for this one, I'll do this one. Y'all, this one's mine's like number 21. This one says log base 2 of 8 equals 3. So the first thing I need is the base for my exponential expression. So the base is going to be the same as the base for the log. So since the base of the log is 2, the base of my exponential will be a 2. So the next question, what's the exponent going to be for my exponential? Well, y'all, the exponent is going to be 3. Good job. Because remember, the log finds exponents. So this means 2 to the third is going to equal the result of a 8. And y'all, this is true. 2 times 2 times 2 does equal 8, okay? So base, exponent, result. Oh, y'all, this one I'm going to do like 24 because it's sort of like the one while ago. They're just going to throw some letters at us. So log base n of a capital M equals a negative x. So y'all, let's see. What will be the base of my exponential expression? N, good job, because remember the base is the same as the base of the log. N, so what would y'all put for the exponent here? All right, negative x, good job. And we know that n to the negative x is going to equal that capital M. Okay, y'all, so that's the trick when you convert. Like I said, next week, um, probably about next Thursday, when we start solving these logarithmic and exponential equations, we got to be able to go both ways, okay? All right, these next examples says use a calculator to find the natural, well, these ones are saying to find the common logarithm. Now, the common log is the one that's on your calculator. The common log is equal to that LOG button on your calculator. The common log is a log base 10, technically, okay? Now, we're going to round 4 decimal places. Whoops. So 4 decimal places. That means 4 spots after the decimal, okay? So y'all think about this one. This one is number 25. And I got the log of 89. Now let me show you this. Let me show you how you think about this. There's no base here, so it's a 10. So let's think what I got. I know that 10 to the first power, look here, 10 to the first power equals 10. I know that 10 squared equals 100, right? 10 to the second power equals 100. 89 is in between 10 and 100. 89 is in between there. So what that means is your answer has to be between 1 and 2. Because remember, we're finding exponents. So That's how you got to think about it. Any number in between 10 and 100 is going to have a log of a 1 point something, something, something. All right, y'all. So this one, I'm just going to use the calculator. Because that's the only way we can do this. All right, let me see what you got. 1.9493. So let's see if Angela's correct. So I'm going to clear that off. My log is right here, and I put in my 89 and enter. All right, so 4 decimal places is where the 3 is. But remember, that 3 depends on the fifth number, which is a 9. So remember, if the number after the one you're looking at is 5 or greater, you got to round that up. So this would be what? 1.9494. Now, y'all, let me remember when I showed y'all the other day when you're rounding, if you'll hit the mode button and go down here where it says float and arrow right and put that on 4, when I put it on 4, it's going to round me 4 decimal places. So clear that screen and hit enter and notice 1.9494. Now, y'all, so remember, look at the fifth spot to see what you're doing to the fourth decimal place, okay? All right, try this one. Log of 57. So, y'all, that's in between 10 and 100 again. So that's going to be a 1 point something. So let's see. So I'm going to take mine off and rounding it 4 spots. All right, what was this? It was a log of 57. All right, so y'all got 1.7559. So 755. Good job, because the 8 has a 7 after it. So we would make the 8 a 9. So 1.7559. Well, y'all, what about this? Log of a negative 46. Oh, good job. Non-real answer. Y'all, that means, think about it. There's no exponent. There's no exponent that I can raise a 10 to turn it into a negative number. So if you're trying to take a log of a negative number, it's going to give you an error. And on MATLAB, you're going to pick B that says does not exist. Hey, I cannot turn a 10 into a negative number no matter what that exponent is, okay? All righty, y'all. Then it says, hey, use a calculator to find the natural log. So remember, the natural log is the LN, okay? And you got the LN button right on front of that calculator. So let's try this one's like number 28. They've got LN of 55. All right, also, let's see. We're rounding at 4 spots. So LN of 55. So what y'all got? 4.0073. So here we go. LN 55. Enter. Oh, perfect. 4.0073. So y'all, the biggest problem in this section really is just getting them rounded off right, okay? All right, 29 is about the same. So let me do one like 30. 30, I got an LN of a negative 0.19. All right, so what y'all putting on that? So is there any way I can turn an E into a negative number? So good job, non-real, which means it does not exist. So we can't turn a log base 10 into a negative number. I can't turn a log base E into a negative number, okay? So y'all think about this. When we do the equations, if we got log x's and those x's, we get, say, a positive number and a negative, we cannot keep the negative answers because we can't take the log of a negative number, okay? So when that happens on the equations, we're going to kick those negative answers out, okay? All right, y'all, let's see. Next thing. Now, this is old school. So what I'll do, um, for these ones, these are going to say find a log using change of base. So y'all, let me ask you this. Um, this would be what you would do if you do not have that log base feature on the calculator. Um, you remember when I went to math and went down and found log base? It let me put these in, but this is for the really old calculators. And if you don't have that log base, this is what you got to do to solve them. So log base tells me this. If I got a log base A of B, that's going to equal a log of B divided by the log of A. So you can take a common log of B divided by the log of the base, which is A. This will give you the same answer as using the log base. Okay? So you would do this if you do not have that log base feature on your calculator. So these start at 31. They want me to find a log base 6 of a 10. So I'll show you both ways so you see what I'm talking about, okay? So y'all, I'm going to clear my screen and clear that. So the first way, I'm going to do the change of base. So for this one, since I got a log base 6 of 10, for this one, I would take the log of 10, close parentheses, and then divide by the log of the base, which was 6. Now watch what answer I get. And I'd have to make that 4 spots. So that'd be 1.2851. Now, the other way, like I said, if you got a newer calculator, you would hit math, go down and find that log base, hit enter, and then you would put in your 6, arrow right, and put in your 10. So newer calculators, I would just use my log base, hit enter, and I get the same exact answer. So the log base, where you take the log of the result and divide by the log of the base, is only if you got older calculators, okay? All right, so y'all, there's like 3 or 4 doing that. So let me do one like my 33 and see what y'all get. Log base 7 of a 10. Um, and y'all do it either way you got to, but round me out 4 decimal places on that answer. Now, if you're doing it to change of base way, on this one, you would do a log of 10 divided by a log of 7. If you got the log base, then you just punch it in like it looks. And you're perfect. 1.1833. All right, so then my very last problem, y'all, is wanting me to graph. So this last one I got wants me to graph two functions. They want me to graph f of x equals 5 to the x, and they want me to graph the inverse equation. So remember that f negative 1 meant inverse, and on this one it's a log base 5 of x. So these functions are inverses of each other. So they sort of want you to look at the graph and see how inverses do, okay? So y'all, I'm going to go to my TI-84. I'm going to clear everything off. I'm going to go to y equals and clear this. So I would do the first function, y equals 5 to the x. I'm going to put 5 exponent x. Then I'm going to go down to y2 right here, and it's going to graph this one using red, I think. So let's see. On this one, I had a log base 5 of x, so I'm going to hit math, go down to log base, enter, and I had a base of 5, and then my result was an x. So y'all got the two graphs. So on this one, you're just going to pick one of the four pictures, and see there's my exponential function, and then there's my logarithmic. They just want you to see that the graphs are opposites of each other, okay? So pick the one that has your two lines drawn like that and be done with it. All right, also that's logarithms. So next class,